Alan Matheson Turing is an English scientist and mathematician. He was born on June 23, 1912 in London, England. Even from a young age, he displayed signs of high intelligence. When Turing attended the well-known independent Sherborne School at the age of 13, he became particularly interested in math and science. Over the next 2 years, Turing studied mathematics and cryptology at the Institute for Advanced Study in Princeton, New Jersey. After receiving his PhD from Princeton University in 1938, he returned to Cambridge and then took a part-time position with the Government Code and Cipher School.
In 1923, Arthur Schubert, a German engineer, developed the first Enigma machine, a machine used for encrypting and decrypting messages. This machine was later used on mass scale by the German army during World War II because it was considered to be uncrackable. In previous encryption methods, each letter was simply replaced by a corresponding letter or symbol. The Enigma machine, however, was different. After each letter, the encryption key would change. The machine had a keyboard and light bulbs representing an encrypted or decrypted letter. Inside, it was composed of a simple electrical circuit, rotors, and a plug board. Each time a letter was pressed, a light would light up and the rotors would turn, changing the electrical circuit, thus changing the key. Each message had to start on an agreed initial setting, and to decrypt the code the receiver would need to use the same initial setting. These were determined using a counter and would change daily. The encrypted message was then sent by radio, and the receiver would also use an Enigma machine to decrypt the messages. The Enigma machine had 5 possible rotors from which you could choose 3. Each rotor had 26 different possible positions. This meant it had over 1 million different starting conditions. The military version also had a plug board which added further possible permutations. In total, the military version would have had 1.5 times 10 to the 18 different possible starting conditions. Because of the mass use of the machine by the German army, it became a top priority for England to find a method to crack the Enigma key within a reasonable time frame. Top mathematicians were hired and many methods were tried, until almost giving up. Every now and then the Allies would get their hands on a copy of the calendar containing the keys the Germans would use. This, however, was just a temporary solution, as they only had a few days written down on each sheet, and the Germans could quickly change the schedule.
So the Enigma machine had one flaw. Each letter could never represent itself. Each morning at 600 hours, the Germans would send out a weather report with a standard format. This meant that the English could guess the phrase that was guaranteed to be included in the message by comparing the phrase to the encrypted text, and remembering that each letter could not represent itself, they could locate where this phrase was within the encrypted message. Using this knowledge and a process of elimination, Alan Turing developed a method to crack the key used. Once this flaw was discovered, Alan Turing and Gordon Welchman designed the Bohr machine. This was a massive machine that used electrical circuits and part of the Enigma machine to crack the key within 20 minutes. The work on the Enigma machine led to the development of secure encryption, which is used in everyday internet access. One of the most predominant is AES, or Advanced Encryption Standards. The basic principle of encryption is that a key is randomly generated. Using this key, the data is reworked according to the key, and the key is also changed.
First, a 4x4 column major matrix is produced from the bytes of data which are being encrypted. This matrix will then undergo key expansion. Round keys are derived from the cipher key. AES requires a separate 128-bit round key block for each round plus an additional one. Each byte of the state matrix is combined with a block of the round key using bitwise XOR. It then undergoes 4 processes. First is a process called subbytes. It is a non-linear substitution step where each byte in the state matrix is replaced by another according to a lookup table. Next is row shift, a transposition step where the last 3 rows of the state matrix are shifted cyclically a certain number of steps. Then the matrix undergoes column mixing, an operation which works on the columns of the state matrix, combining the 4 bytes in each column. Lastly, a final round key is added to the encrypted matrix to complete the cycle. These processes are then repeated for a predetermined number of cycles according to the bit size being encrypted.